Hey London and any other stats kids that are watching this. Today I'm gonna be going over the last couple units before your final. I know it's way before your final, but I've just gone over all the other units, so I just have these last two. I have no idea where you actually are in the course. Hopefully I'll see London on Monday. Um, Anywho, let's get into confidence intervals. So, what is a confidence interval? It's a range of values that is likely to contain a true population mean. It gives you an estimate of where the true mean lies within a certain level of confidence. So the reason you're using a confidence interval is to express the uncertainty around a sample estimate and provide a general range that includes that likely includes the population mean. In statistics, you have to use the words likely or uncertainty. There's nothing definite in statistics. Um, for example, a 95% confidence interval means that uh, I am 95% confident that the true population mean falls within this interval. Um, so constructing a confidence interval for the mean. So to build a confidence interval for the mean when the population standard deviation is known or you have a large sample size, you're going to use the formula mean confidence interval equals the mean plus or minus your z-score times your standard deviation over the square root of n. Yeah, the way so you can draw that. All right. So a confidence interval is equal to the standard mean plus or minus your z-score times the population standard deviation over the square root of n, which is your sample size. And that standard deviation over the square root of n is the standard error of the mean. That is different from standard deviation. I'm sure you've learned that already. Uh, so z-scores for confidence levels. So the z-score determines how many standard errors that you move away from the mean to capture the desired confidence level. So there's three key z-scores: 90% confidence level, 95% confidence level, and 99% confidence level. So if it's 90%, the z-score is 1.645, which means that 90% of the values of your data lie within 1.645 standard deviations. So let me draw a standard bell curve here. Um, so say that everything from these two black dashes here is 1.645 standard deviations, then all this that's in here would be 90% of your values. Um, Now for 95%, oh wait, just in case you can see that. Now for 95%, your z-score is going to be 1.96 typically. Other times you'll see it as just flat out 2. Basically that means 95% of your values will lie within 1.96 standard deviations. And then finally, 99% confidence level, your z-score is going to be 2.575 is the one they like to use. Um, and that is means 99% of your values. So almost every single one of your values is going to lie within 2.575 standard deviations. Um, Those are going to be on your standard normal table, which I'm pretty sure Professor Karsten gives to you on all your exams, like in a little packet or whatever. So you should be good to go with those. Um, so the margin of error is next. Your margin of error is the amount that's added and subtracted from the mean to create the confidence interval. So the equation for margin of error is the margin of error is equal to your z-score times your standard deviation over the square root of n. Now that should look familiar because we just wrote that as part of the equation for um, confidence interval. So there are a couple ways you can reduce the margin of error as a way to better your confidence interval. So increasing your sample size, when you add more numbers, you can decrease that margin of error because you have a better general sense of where that data lies. Um, Another way to reduce the margin of error is to lower the confidence level. So choose a 90% instead of a 99 to reduce that z-score, and that which shrinks the margin of error. But the cost of that is you have less confidence. So you want to have as reasonably high confidence as you can. You can't say 99% for everything, but maybe 95 or 90. And then finally, reduce the variability of the standard deviation. So if it's possible, you use more precise. This is more like in situ, like the field, rather ex situ, which is like you're reviewing all this data. But like when you're actually doing data, use more precise measurement techniques. That should just go without saying. Um, and that's it for this video. Um, yeah, and then that's about it. Unless you want help with something specific. See you then.